dA by dt plus P into I, that is equal to Q, is like this. So for this type of equations, I of t is equal to, we already discussed with this concept, it is k into e power minus pt, the solution, into e power minus pt integral e power pt into q into e power pt dt, q into e power pt dt. So this is the solution for this type of expressions. So here p is 150, q is 250. Substitute to get this solution I of t. I of t is equal to k into, k is an arbitrary constant, we can get this value by using the initial conditions. That means by substituting t is equal to 0 in this expression, we are able to get the value of k. So e power minus 150t plus e power minus 150t integral e power, q value is 250 into e power 150t dt. So this is the expression. Now k into e power minus 150t plus, so here 250 is the constant, e power minus 150t. If I integrate this one, e power x, e power ax is equal to e power ax divided by a, that is e power 150t divided by 150. This is I of t. So this e power 150t, this one will get cancelled here. So 250 by 150 is k into e power minus 150t. This value will get it as 1.667. Now this is I of t. I need to find the value of k. Use the initial conditions. The initial conditions is at t is equal to 0, the value of I of 0. I of 0. What is the value of I of 0? We already calculated that I of 0 is 2.5 amperes. So that is 2.5 amperes. So use this expression here. I of 0 is equal to 2.5, that is equal to k into e power minus 150 into 0 plus 1.667. So this is k into, it is 1, e power 0 is 1 plus 1.667, that is equal to 2.5. Now the value of k here is, if you subtract this 2.5, this 1.667 from 2.5, I will get the value is 0.833. Now substitute this k value in this expression. So we will get I of t is equal to 0.833 into e power minus 150t plus 1.667. So this is the I of t. This is how we can get the solution for this type of problem. So this is the expression 1.667, 0.833 e power minus 150t for t greater than 0, for t greater than 0. Next next problem. Different types of problems I explained here. So up to now we have seen for DC supply, these things, this I of t we calculated. Now for AC supply, if you apply the sinusoidal voltage as an input, then how to solve this type of questions? It is somewhat difficult. Okay. So for the network shown in figure, a sinusoidal voltage source V is equal to 150 sin 500t plus theta volts is applied at a time when theta is equal to 0. Okay. So theta is equal to 0 here. When theta is equal to 0, this much of voltage is applied for this circuit. That means applied means I am switching on at a time theta is equal to 0. Theta is nothing but omega t. That is omega t is equal to 0. That is t is equal to 0. That means at t is equal to 0, the switch is on. The meaning of this sentence is at t is equal to 0, we apply the supply of this much of voltage for this circuit. Find the expression for the current I of t. So I need to find this expression I of t. So how, this is the expression we will get. So how to find this expression, how to solve this type of question, let me explain here. So the same procedure I will apply. The procedure here is at t is equal to 0 minus, at t is equal to 0 minus, what is this switch is in sinusoidal voltage source is applied, that means the switch is in open position. So the switch is in open position, so this is the condition. Right. It is 0.2 Henry and it is 50 ohms. It is the voltage 150 sin 500t plus theta. So initially the current that is flowing through this is I of 0 minus. So no supply is connected to this RL circuit. So the current value is I of 0 minus is equal to 0 amperes. We know that whatever the current that is flowing at 0 minus, the same current will flow at 0 plus, because the inductor doesn't allow the sudden changes in current. So I of 0 minus is equal to 0, I of 0 plus is equal to 0, I of 0 is also 0 amperes. Okay, we calculate the value of I of 0, which is used in the initial conditions to calculate the value of arbitrary constant k. So now for t greater than 0, for t greater than 0, for t greater than 0, draw the circuit. So this is the sinusoidal voltage and this was connected to this put. This is okay. Now this is an inductance. Previously there is no current flowing through this, so I need not to place this I naught here. Okay, this is 0.2 Henry, 0.2 Henry, it is 50 ohms and this supply is 150 sin 500t plus theta. So this is the supply I of t. Now apply the KVL for this equation, for this loop. 150 sin 500t plus theta, this plus and minus, this plus and minus, this plus and minus, minus 50 into I of t minus VL of t. VL of t is L into di of t by dt. L value is 0.2, di of t by dt is equal to 0. Now write down this expression like this: 0.2 into di of t by dt plus 50 into I of t, that is equal to 150 into sin 500t plus theta. So write down this equation like this again, rewrite this: di of t by dt plus 50 by 0.2, that means 1 by 0.2 is 5 or 5, 1 by 0.2, 10 by 2, that is equal to 5. So 5 into 5, 50, 250, 250 into I of t. So 150 into 5, so it is 750, 750 into sin 500t plus theta. So it is like di by dt plus p into I, that is equal to q. So the solution for this type of non-homogeneous first order differential equations here is I of t is equal to k into e power minus pt plus e power minus pt integral q into e power pt dt. So this is the solution. So here p value is equal to this one, q is equal to this one. P value is 250 and q value is 750 into q value is 750 into sin of 500t plus theta. Substitute here I of t is equal to k into e power minus 250t plus e power minus 250t into q, 750 into sin 500t plus theta into e power 250t dt. Now 750 is a constant, it is not a function of time. I can take it out from the integration. So this value is k into e power minus 250t plus 750 into e power minus 250t, already it is here, integral e power 250t into sin 500t plus theta dt. So this is I of t. And you see there is a formula for e power ax sine of bx plus c. The formula for this one is e power ax divided by a square plus b square into a sin bx minus b cos bx.